Hello, everybody. Welcome back to another video. I hope you're all doing well. In this video, we're going to be taking a look at structural isomers. Now, before we get into this topic, I wanted to let you all know that this week was actually my first week at university, and I am taking chemistry courses at university because I'm a biochemistry student. So the very first topic that we learned in chemistry at university was to do with isomers. We were learning about isomers. So you can imagine how important they are. And trust me, learning isomers well in IB will give you all the help you need to do well in university level chemistry. Believe me in that. It's only my first week, but I can tell that if I did not know IB chemistry well, I would have not been able to know what university level chemistry is. So make sure that you know these topics well, and hopefully I can also assist you in that process. Now, there are many different types of isomers, as you can probably see from this graph over here. If you're wondering where I've got this graph or diagram or whatever you want to call it, I've got it from the Cambridge IB chemistry textbook, and you can find an ePDF version of that textbook on my Google Drive. If you're interested, just let me know and I'll give you a link to that drive and you can use it. But moving on, I'm not going to be looking at stereoisomers today. This is HL. This is an HL topic. I'm not going to be looking at that today. That's a video for another day. So I'm going to be only looking at structural isomers. And this obviously for structural isomers, both SL and HL students need to know it. But SL students only need to know about structural isomers. You do not need to know anything about stereoisomers. It will not be asked in your exam. SL students, not HL students, you will need to know both types. Lucky you. So let's move on. Now, what are structural isomers? Really, there are many different types of isomers, as you can see, right? And the simplest one out of all of them are structural isomers. And as you can see from this definition over here, the structural isomers are basically two or more compounds that have the same molecular formula, but different structural formulas. And the structural formula basically entails that the atoms, when you draw the structural formula, the atoms are actually joined in different ways. And that gives you a completely new type of compound. And two compounds which share the same molecular formula but have different structural formulas, the structure of the molecule, when they're different but the molecular formula is the same, then you call them structural isomers. And let me give you a few examples to visualize, so you can visualize what exactly I'm talking about. So let's say we have a molecular formula of C4H10. Now this molecule, you can actually draw two completely different types of molecules from this molecular formula. The first thing you can draw, as you can probably tell, or the first thing you probably thought of, is butane, right? Because C4, so that's a butane. And butane would look something like this. I'm not drawing the hydrogens because it's just a waste of time, but I'm sure you understand what I mean, right? Anyways, for the first drawing, I will put them in anyway, so you guys don't get confused. So yeah, there we go. This is butane. It's a 4-carbon compound and it's an alkane standard. So this is butane. But you can also draw something else from C4H10, which is a totally different compound. And that is this right over here. And yeah, there you go. What is this compound? Well, this compound is 2-methyl propane. And it has the exact same formula as butane, but the structural formula is completely different. These two molecules are completely different from one another, yet they have the same structural formula, which is C4H10. We can verify that. So let's look at 2-methyl propane. 1, 2, 3, 4 carbon atoms, and 1, 2, 3, 4, 5, 6, 7, and 7 plus 3, 10 hydrogen atoms. Now, these both butane and 2-methyl propane are structural isomers because they firstly have the same molecular formula C4H10 and they have different structural formulas. That means the atoms are joined in different ways. And if you notice something, what really made butane into 2-methyl propane or vice versa? Well, what we did was we took this methyl group CH3 and we replaced it with this hydrogen, right? We just replaced these two. And what did you get? You got a completely new compound, which is 2-methyl propane. So what I'm getting at is, if in an exam you are told to draw the structural isomers of something like C4H10, what you have to do, or what I would suggest you do, which is very helpful technique, it helped me a lot, and my tutor taught me this. Look at this chain. First, from C4H10, if you're given this molecular formula, draw out the first compound that comes to your mind, right? And typically that would be a very simple compound like butane, right? Because that's just simple. You probably won't think of 2-methyl propane first. You'd probably think of butane. I would think of butane. So you draw the simplest compound first, which in my case would be butane. And if you look at this and imagine this to be a string of carbons, so what you do is you take the very last carbon molecule, you take it away, and you put it on the middle atom, which in this case would be this carbon. So if I took this away, if I just remove this, then it would have 3 carbons, and I'd put this on the middle carbon. I will not put it on this carbon or on this carbon again, because then I just end up with the same compound. I just end up with butane all over again, right? So doing this is not creating a structure. So imagine I do this. Just imagine I do this. I remove this and I put CH3 over here. This is not a structural isomer. This is not a structural. This is still butane. This is still butane. This is not a structural isomer. It's the same compound. So don't do this. If you do something like this, you're not going to get any marks because you've not given a structural isomer. Both of these are butane. It's the same thing. You've just drawn it a bit differently, if that makes sense. So make sure the isomer that you give is different. It is a totally different compound from what you had drawn in the first place. That is a structural isomer, methyl propane. I'm going to go and I'm going to take another example so you guys understand what I'm doing over here. I am going to take the example of C5H12. Let's take C5H12. Okay, I'm just going to erase this so that I have some more space. All right. Now I'm going to draw C5H12. C5H12. All right. Now this is the molecular formula, and the first thing that comes to my mind, 5 carbons. Okay, it's going to be pentane, right? Simple. It's an alkane. Not much to think about over there. We can draw the 5 carbons. 1, 2, 3, 4, 5. And I'm just going to indicate that there are hydrogens using the lines. There we go. This is your pentane. This is pentane. Now I want to draw a structural isomer for this. What did I tell you? What is the first thing that we do? Take out, remove the last carbon, and put it on the middle carbon of the remaining chain. So if I remove this carbon, so supposing I remove this carbon, now this compound would look something like this. And I have two middle carbons left, right? I have this carbon and this carbon. You can choose to put it on any one of them. I'm going to put it on this one. And the hydrogen that was present on this carbon can be replaced over here. It can be put over here. So this compound is stable. Now I have created a totally new compound. The earlier compound was pentane. This compound is 2-methyl butane. This is a totally different compound. So you see what I've done. Now, if I want to create an other isomer from this, same rule, remove the carbon from the other end now. We remove the carbon from one end. Now I want to remove the carbon from the other end. So this carbon over here, I'm going to remove this carbon. Now, like I said, place it on the middle carbon. The middle carbon out of these three would obviously be this one now. So I'm going to place it on this. And the hydrogen which was attached to this carbon earlier will be present over here now. Now this is again a totally different molecule. This is 2,2-dimethyl propane. And all of these, I've shown you three isomers so far. I have shown you pentane, which is the first one, the simple alkane. I showed you 2-methyl butane, and now I've shown you 2,2-dimethyl propane. And all of these have the exact same molecular formula, which is C5H12. But they are all different molecules. And in fact, with C5H12, you can draw some more isomers as well. And before I tell you what these isomers could be, I want you to try it out yourself and see what you get. Now, if you tried that out and you're thinking, well, if you drew something like this, so if supposing you drew something like this, if you drew something like this is wrong. Okay, you've fallen for my trap. I've trapped you. This is wrong because again, you have drawn the same molecule just in a different shape. This is 2-methyl butane, right? So don't do that. Don't make the mistake of just changing the orientation of the carbon and expecting it to be a new molecule. No, that's not the case. You have to be very careful. You have to ensure that you are drawing a totally new substance. You're not repeating something that's already there. It's easy to forget, easy to fall for that trap. If you fell for that trap, you know you need some more practice. So please practice such questions and use the method I've told you. Pluck out the carbons from either side of the chain and attach them to the carbon, which you think will give you a new molecule. And this is something you have to do. It's a process of trial and error. Right now in IB exams, they're not going to expect you to draw too many isomers. They are going to give you the max amount or the maximum number of carbons they're going to ask you to draw isomers from is 6 carbons. So the maximum they'll go to is probably C6H14, right? Which is hexane. So don't worry too much about that. Just make sure that the molecules, the isomers that you're giving are actually isomers and they're actually structurally different from one another. They're not the same. Because if you do the same, that's the worst thing you can do. You're not going to get your marks. So that is it for this video. I hope I have begun to make you understand the concept of structural isomers. Please, I would highly recommend you to practice these type of questions. Everything in this video I have explained is enough for you to learn about structural isomers. This is all, everything you need for structural isomers is all in this video. You just need to practice now. Practice is the key. Just take random molecules, right? Take molecules like, I don't know, like I said, C6H14, right? Just take that and draw isomers. Do it in your free time, right? Practice it. And the more you practice, the better you'll get a hang of it. Maybe you can repeat these questions as well. You can repeat C5H12. You can repeat maybe C4H10 if you want. So practice. And that is it for this video. Thank you so much for watching. I hope I have helped you learn about this topic a bit better. If you have any other questions regarding this concept or any other concept, please feel free to reach out to me. I'll be more than happy to help you. I help students almost on a daily basis. So I'll be more than happy to help you as well. That is it. Take care of yourselves. Goodbye. And I will see you in another video with another question.